So what do you do if your sample is small? As I mentioned before, if your sample is small, you're actually going to be turning to a different kind of sampling distribution than the normal distribution. And again, the distribution that we're about to meet is going to come up a couple more times in this class, so even though we're not going to do much with it this week, I do want you to be familiar with what it is. And specifically, we're looking at something called a t-distribution. And t-distributions have the quality that they have different shapes for different sample sizes. And specifically, when the sample is greater than 30, a t-distribution is shaped exactly like a normal distribution. And this is why you can use them interchangeably if you have a sample size that's bigger than 30. So you can use the normal distribution like we did in the last example, or you could use this t-distribution formula, which again is more versatile because it includes more sample sizes. But if you have a sample that's greater than 30, you're going to get exactly the same results whether you use a normal distribution or a t-distribution. And that's because the t-distribution is shaped like a normal distribution for samples that are greater than 30. When your sample is less than 30, on the other hand, the t-distribution will have different shapes. And the smaller the sample gets, the shorter and fatter the t-distribution gets. And in t-distribution, sample size is expressed using something called degrees of freedom. And this is something else that we're not going to get into great depth in this week, but we will see again as the class goes on. And depending on what you're using a t-distribution for, your degrees of freedom may be calculated in different ways, but typically, smaller degrees of freedom correspond to a smaller sample. So what you can see in the graph on this slide there is that for smaller df, or degrees of freedom, you have a shorter and fatter graph. And so that's the shape of the sampling distribution for smaller samples when you're looking at t-distributions. And what the shorter, fatter graph means is that you're more likely to get sample means that are further away from the mean because those lines are higher up when you're further away from the mean. So it spreads out the probability of getting different sample means a little bit. T-distributions also have properties that are similar to normal distributions. And specifically, there's something called a t-score or a t-statistic. I may use those interchangeably, which functions exactly like a z-score. The only difference is that you're putting it on the t-distribution. So with this, I'm going to hop back over to the document camera, talk a little bit more about these t-distributions with some of my artwork to go along with it, and then talk about how this would fit into the small sample confidence interval formula.